So in week 5 in our geometry lesson, we talked about building a shed, and this shed is now back. The floor is 12 by 16, so the area is 12 times 16, 192 square feet. What we're looking at here is just insulating the floor of the shed. Maybe this is going to become your new art studio. Insulation comes in packages that cover 37.5 square feet. So how many packages will I buy? You're going to need several packages. We're trying to find out how many times this fits into 192. If we're figuring out how many times, it's a division problem. 192 divided by 37.5 is 5.12 packages. Now if we were rounding, we would say that 5 packages makes sense, but we need a tiny bit more, so unfortunately we need to buy 6 packages. So 6 times $45.99 looks like you're going to be spending $275.94 on this rock wool insulation. Now I wanted to show you multiplying rates for this problem, and the result is a little different. Here's my setup. Square feet cancels square feet. Package cancels package. When I work that out, I get $235.47. The reason this is lower is because you're calculating the cost of exactly the insulation that you use, not all the insulation that you would have to buy. So if you only paid for what you could use, you'd only spend $235.47. On question E, I put these two rates together, and I'm trying to get you to understand what the result means. So clearly packages and packages are going to cancel. So we're going to need to do $45.99 divided by 37.5, and I get 1.2264, or 123, $1.23 per square foot. Packages cancel, so we end up with dollars per square foot. You can abbreviate that S period F period. So that's the cost of a square foot of insulation. And if you were a contractor, you might want to keep this number somewhere for generating bids. So a couple more questions here. This is starting to get into the CO2 emissions, which we'll be focusing on in our next section as well. 1 gallon of gas emits 8,700 grams of CO2, carbon dioxide, when burned. Our car gets 30 miles to a gallon of gas. Those are two rates. We're going to put them together, and we're going to get our CO2 output per mile. Grams per mile will be the result. So here is the first rate, 8,700 grams per gallon. The next rate is 30 miles to the gallon, and I flipped it. I flipped it so that gallons would cancel. And I'm going to end up with grams per mile. If you started with 30 miles to the gallon, you would end up with the upside down version of the answer. And this happens all the time. When you see that you got miles per gram instead of grams per mile, you just try again, make everything upside down, and you'll be on the right track. This is a similar problem. The 8,700 grams per gallon is a fact for all. It's not even for cars. It's just if you burn a gallon of gas, this is how much CO2 is emitted, regardless of your vehicle. For a car that gets 22 miles to the gallon, what is the CO2 output per mile? So we repeat the same exact process, but because this car has worse gas mileage, worse fuel efficiency, then that car has higher emissions per mile. So the grams of CO2 that's coming out of your tailpipe, we are weighing it. Even though it's a gas, it has a weight or a mass, and that's the amount of CO2 emissions for every mile that you drive. This is what's causing climate change. And you can calculate the math of it. And I'm just giving you a little taste of how it all works.